Good morning. This is Teacher Annabelle and welcome to physics class. Before we begin our lesson, I would like you to prepare the following things with you. First, your physics book. Second, a pen, a copybook, and a calculator to be used in any mathematical equation later. To begin with, I am going to show you this picture on the screen. As you can see, on the left side, you can observe a girl who seems to be happy, lively, and active. However, on the opposite side, you can observe a girl who looks so sleepy, weak, and inactive. What do you think is the factor that makes the other lively and the other one inactive? That's right, energy. Energy is one of the most important things for all living things. In order for us to do our jobs and to fulfill our task, we need to have energy. We all know that we get our energy from the food that we eat. However, plants get their energy from the sun. In science, we describe energy as the capacity to do work. Here are the different forms of energy. We have mechanical energy, chemical energy, electrical energy, sound energy, light and radiant energy, nuclear energy, and heat and thermal energy. Energy may be the most familiar concept in science, yet it is one of the most difficult to define. Why? That's because we can only observe the effects of energy when something is happening. That means we cannot see the energy itself, but we can only observe the effects of it. It is when energy is being transferred from one place to another or transformed from one form to another. Let us talk more about energy. To begin with, let us observe some related concepts such as work and power. I would like you to open your books on page 144. Our main objective for today is to first define work and power, identify the two forms of mechanical energy, and describe the three forms of potential energy. How can you describe the word work? I know most of you are thinking about specific job or task inside your home or outside. In science, we describe in science, work is done when a force acts on an object in the direction that the object is moving. Remember, if there is no movement of an object in the same direction as the force acting on that object, there is no work being done. In mathematical equation, you can write work is equals to force times distance. And remember, the unit that we can use for work or the unit to measure work is in newtons times meters or what we call joules. To begin with, I am going to show you this picture on the screen. As you can see, on the left side, you can observe a girl who seems to be happy, lively, and active. However, on the opposite side, you can observe a girl who looks so sleepy, weak, and inactive. What do you think is the factor that makes the other lively and the other one inactive? Sometimes work is done against another force which changes the object's position and stores energy. Example, looking at the archer on the picture. As you can see, there are two forces acting against each other. First, the force exerted by the archer. Second, the force exerted by the elasticity of the bowstring. Same when you do chin ups, you do work against your own weight or gravity. Sometimes work is done to change the speed of an object. Example, when you bring an automobile up to speed or in slowing it down. Get ready with your pen, copybook, and calculators. Let us think about the given mathematical equation on the screen. Suppose that you apply a 60 Newton horizontal force to a 32 kilogram package, which pushes it for 4 meters across a mailroom floor. How much work do you do on the package? Remember our formula. In order to get work, we must multiply force and distance. Your force is 60 newtons, while your distance is 4 meters. To get the work, we have to multiply 60 times 4. 60 times 4 is equals to 240. And remember, since you are looking for work, the unit that you should use is joules. Let us talk more about energy. To begin with, let us observe some related concepts such as work and power. I would like you to open your books on page 144. A machine does work by transferring energy from one place to another or transforming it from one type to another, making it more convenient for us to do our task. The other concept related to energy is what we call power. Power is the rate at which work is done. In mathematical equation, we can describe power by dividing work done and time interval. Remember, the units for power is joules per second or watts. Mechanical energy. This type or form of energy is the energy due to the position or the movement of an object. The two forms of mechanical energy are kinetic and potential energy. When you are in the lower grades, you've been very familiar with these two forms of energy. You know that kinetic energy is the energy in motion, while our main objective for today is to first define work and power, identify the two forms of mechanical energy, and describe the three forms. One example of potential energy is gravitational potential energy. Gravitational potential energy is energy an object possesses because of its position in a gravitational field. The amount of work to lift an object is equals to its gravitational potential energy. In mathematical equation, we can describe gravitational potential energy by multiplying the object's mass times the object's acceleration due to gravity times its distance above a surface. The other example of potential energy is elastic potential energy, the energy associated with stretch and deformation. Example, when you are stretching or compressing a spring or a rubber band. The last example is chemical energy. The chemical energy in fuels is also potential energy. It is an energy of position at submicroscopic level. This energy is available when the positions of electric charges within and between molecules are altered and a chemical change takes place. You can get again your copybook and pen and let us think about this mathematical problem written on the screen. You lift a 100 Newton boulder for about 1 meter. We have three questions below. First, how much work is done on the boulder? Second, what power is expended if you lift the object in a time of 2 seconds? Third, what is the gravitational potential energy of the boulder in the lifted position? You have 1 minute to answer, and the timer starts now. Mechanical energy. This type or form of energy is the energy due to the position or the movement of an object. The two forms of mechanical energy are kinetic and potential energy. When you are in the lower grades, you've been very familiar with these two forms of energy. You know that kinetic energy is the energy in motion, while potential energy is the stored energy. This ends our lesson. Thank you for listening. Don't forget to answer your homework written in your weekly plan.